In this video, we will do some more examples involving the chain rule. So I want to begin with this example here. So let's let b of x be the function x minus 4 to the 10 over 1 minus 3x to the 5. Find all values of x where the tangent line is horizontal. Alright, so I want to have you all pause the video for about 3 minutes to try this question on your own first. So 4, 3, 2, 1, pause the video. Pause the video for about 3 minutes and really try this question on your own. Alright, so hopefully you've done that. Hopefully you've paused the video for about 3 minutes to try this. If not, go ahead and do so now. Okay, so let's go ahead and talk about it together. So this question is saying that the tangent line needs to be horizontal. So if the tangent line is horizontal, that means its slope, the slope of the tangent line, is equal to 0. That's what it means if our line is horizontal. Its slope needs to be equal to 0. Okay, and then the slope of the tangent line, that's b prime of x, that's the derivative. So this is saying that the derivative needs to be equal to 0. Okay, so we've broken down what this sentence was saying, and we've translated it to a mathematical statement, which is a key part of answering this. All right, so now let's take the derivative. All right, so to take the derivative, we are going to need to use the quotient rule. So let's use the quotient rule to take this derivative. So we'll get b prime of x, our derivative, is equal to, let's remember our memory trick for a quotient rule. It's low d high. So low d high, and then minus, let's just write that part for the time being. So low, the bottom, would be 1 minus 3x to the 5th. D high means the derivative of the top. So times the derivative, all right, d dx, of the top, x minus 4 to the 10. And then minus high, d low. Let me also put a multiplication here. Okay, so we're going to get a minus high. High is the top function, x minus 4 to the 10. D low means times the derivative of the bottom. So times the derivative of the bottom, 1 minus 3x to the 5. Okay, so that's the numerator using quotient rule. And the denominator is low squared, which is the denominator squared. So that'll give us 1 minus 3x to the 5, that being squared. Okay, so we've set up our quotient rule here, but there's still two derivatives to take. There's this d high term, and there's this d low term. We still got to do those derivatives. All right, so let's do some review. So from last time, when we took the derivative of something to a power, something to the n power, so I'm going to call the inside function just f of x. Taking this derivative requires the chain rule. The chain rule. So there's an inside function and an outside function here. The outside function, well, let's just write outside function, and let's write inside function. Okay, so there's an outside function, there's an inside function. Okay, so the inside function is f of x. F of x, whatever that happens to be, is what's being plugged inside of this nth power. And the outside function is x to the n. So we might be wondering, wait, where's x to the n? I see something else to the n. I see f of x to the n here. And the reason for that is there's already something that's been plugged into the x in x to the n. F of x has already been plugged into the x. And that's why the x is no longer there. That's why it's f of x being raised to the n power. All right, so there's an outside function, there's an inside function. So we need chain rule to take this derivative. And the chain rule says that when we do the derivative, first we deal with the outside part. So we deal with the nth power thing. We bring that n down. And the new power is going to be n minus 1. But the chain rule says when you do that, when you take the derivative of the outside function, keep plugging the same inside thing, which was f of x, into it. So I'll keep plugging in f of x into it. Okay, but then there's one more step, which is now you multiply by the derivative of the inside. So we multiply by the derivative of f of x, our inside function. Okay, so that was a bit of a review from last time when we first introduced the chain rule. Okay, so now let's apply that to our derivatives that we have here. So we have b prime of x is equal to 1 minus 3x to the 5 times this derivative, so the derivative of x minus 4 to the 10. Okay, so taking the derivative of that, the 10 will come down, and the new power will be 9. We keep plugging in that same inside thing into it, so we keep plugging in x minus 4. But we have to multiply that by now the derivative of the inside. We have to multiply that by the derivative of x minus 4. That's the chain rule step. We have to multiply by the derivative of the inside. Okay, all right, and then we have minus. We still have this other x minus 4 to the 10. Okay, and now we have to do the derivative of 1 minus 3x to the 5. So that's going to be chain rule as well. First we deal with the outside part, that's the power. Bring that power down, subtract 1 from it, so the new power is 4. Okay, so we're taking the derivative of the outside portion so far. When we do that, keep plugging the same inside thing into it. So 1 minus 3x. Okay, but now there's that chain rule step where we have to multiply this by the derivative of the inside. Multiply by the derivative of 1 minus 3x. Okay, let me zoom that out a little bit. It's getting kind of long. All right, so that is what we have on the numerator. And on the denominator, we will have 1 minus 3x. And then when we have a power to a power like this, like we have this to the 5, and then that whole thing being squared, we multiply the powers. So 5 times 2 is 10. All right, so now let's simplify. So we have b prime of x equals, so the derivative of x minus 4, that's not too bad, that's just 1. The derivative of 1 minus 3x, also not too bad. That's just negative 3. All right, so now simplifying what we have on the numerator, the constant term in front is a 10, because I have 10 times 1, and that's 10. And then I'll have a 1 minus 3x to the 5, x minus 4 to the 9. And then we have our minus sign. From the next term, we're going to have 5 times negative 3, which is negative 15. So we'll have a negative 15. But double negative becomes a positive, so that becomes a positive. And then we also have an x minus 4 to the 10 and 1 minus 3x to the 4. All over 1 minus 3x to the 10. All right, let's scroll it down a little bit so I give myself some more room to write. Okay, so we have this whole thing. And remember that we are going to need to set this equal to 0. Because we want to figure out when the slope of the tangent line equals 0. That's when the tangent line is horizontal. Okay, so I noticed that there's a bunch of common terms on the top. So let's factor. So if we factor, let me start writing this b prime of x. If we factor, let's see, with the 10 and the 15, I could take out a 5. That's common. What else is common? We could do 1 minus 3x to the 4. That's common. That's a smaller power. There's 5 1 minus 3x's in this first term. There's 4 1 minus 3x's in the second term. So I can take out 4 of them. In the same sort of way, I can factor out x minus 4 to the 9. And that's everything that's common. Now I have to write everything that's left over. So from the first term, when I factor this stuff out, I'll be left with a 2, because 10 divided by 5 is 2. And I'll also have a 1 minus 3x. That's all I'll have left over from the first term. So now let's move on to the next term. So from the next term, all of this, when I take out the 5, I'll be left with a plus 3, because 15 divided by 5 is positive 3. And we'll also have an x minus 4, and that's it. We took out all of the 1 minus 3x's from that term. Okay, so now let's close that bracket, and then all over 1 minus 3x to the 10 equals 0. All right, so now we can simplify this a little bit further, because I noticed that there's something common on the top and on the bottom. there's this 1 minus 3x to the 4 on top, 1 minus 3x to the 10 on the bottom, so we can cancel them a bit. We can cancel them, and I'll be left with 1 minus 3x to the 6th on the denominator. All right, so we have 5 times x minus 4 to the 9. Let's start to expand this thing in the bracket. So I'll get 2 minus 6x. Distributing the 3, I get plus 3x minus 12. And then all over my denominator, 1 minus, whoops, let's write that better. 1 minus 3x to the 6 equals 0. So now let's multiply both sides by the denominator to get rid of the fraction. So getting rid of the fraction is going to be a good idea in general. And I can do that by multiplying both sides by the denominator. So doing this, I end up with 5 times x minus 4 to the 9. And then in the brackets, I will get negative 3x minus 10. And then this equals, on the other side, 0 times anything is just 0. Okay, so this is factored now. And so once it's factored, I can go ahead and say what x equals. From the first parentheses, I get x equals 4. That's what makes this first parentheses term become 0. And then from the bracket, if I set negative 3x minus 10 equal to 0, we end up getting that x is negative 10 over 3. And those are our answers here. All right, so I just want to recap a key observation about problems like this, where I have to take a derivative, and then do something with it. Like here, I wanted to figure out where the tangent line was horizontal, so we had to take the derivative. In this case, we had to use the quotient rule and the chain rule to do that. And then we had to do some algebra. We set it equal to 0 to figure out when the slope was 0, and then solve that equation. Often, that algebra portion is the most challenging part of these calculus questions. In general, I feel like that's true. Calculus itself, like taking a derivative, using these derivative rules, once we get comfortable with them, it's not bad. But what can be tricky is the algebra. The algebra in particular can be one of the things that makes these calculus problems harder. Okay, so you might remember that we saw fractions and equations like this back when we did our assessment and when we did some of our pre-calc and algebra review. And that was kind of by design. It was to get you familiar with doing some of the algebra pre-calculus thing, reviewing that stuff. That would show up again in calculus. We really focused that review on the types of things that we would need in calculus. Okay, so let me just erase that comment. All right, let's do another example. Okay, so in this example, let's let g of x be this function. And I want to find dg dx. That means find the derivative of the function g with respect to the variable x. All right, so for this problem as well, I'd like you to pause the video for about 2 minutes to try this on your own first. So 4, 3, 2, 1, pause the video. Pause the video for about 2 minutes to try this question. So it's really important, especially with the chain rule, to be getting the practice doing problems like this. So it's super, super important to pause the video and actually try these questions. The chain rule is perhaps the most complicated of these rules to master, because often using it, we have to apply it in ways where we combine it with the quotient and the product rules, and that can be challenging, so it's important to get that practice. All right, so let's talk about it together. So the first thing that I'm going to want to do is, we know from when we've taken the derivatives of basic things like square root of x, that to do that, I need to rewrite it as a power. Let's rewrite all the roots here as powers. So this big square root becomes a big 1/2 power. And then inside we have 3x plus, and then we have another big square root, so that's another big 1/2 power. And then inside of that we have 2x plus x to the 1/2. Okay, so I can rewrite it this way, and now we are going to be ready to take the derivative. All right, so I've kind of just copied that at the top of the page now. To do this derivative, we're going to need the chain rule. Because I definitely see an outside function, I see this whole thing being raised to the 1/2 power, and there's everything that's sort of inside of that. So all of this is sort of the inside portion. So we're going to need some chain rule here, so let's do that. So if I take the derivative, g prime of x, so first I deal with that outside portion, that 1/2, the power is going to come down, and then I subtract 1 from the power. So that'll give me a negative 1/2 up there. When we do that, chain rule says keep what we have inside the same. So keep plugging in 3x plus 2x plus x to the 1/2, close that parentheses, and then 1/2 power. So keep that the same. And now do the chain rule step. So now we multiply this by the derivative of the inside stuff. So the inside stuff is 3x plus 2x plus x to the 1/2 to the 1/2. Alrighty. So the stuff that's in front here is going to stay the same. So we have g prime of x equals, all of the stuff in black will stay the same, 1/2 and then times 3x plus 2x plus x to the 1/2 to the 1/2, that whole thing to the negative 1/2. So that just stays the same. But now we have to do this next derivative. So to do that next derivative, let me put a bracket. Let me give myself some room for this. So first, the derivative of 3x is just 3. So that one's not bad. And then we have this 2x plus x to the 1/2, that whole thing to the 1/2 power. And that requires chain rule again. That requires chain rule again because there's an inside and an outside function. So what's inside is this 2x plus x to the 1/2. That's what's inside. And the thing that's outside is the fact that I have this 1/2 power. It's like my outside function is x to the 1/2 because I have this 1/2 power on the outside. All right, so using the chain rule, it says, we'll first deal with that outside portion. Let's bring that power down. So bring that 1/2 power down. Subtract 1 from the power. That'll give me a negative 1/2 up there. When we do that, keep the inside the same. 2x plus x to the 1/2. But now we have the chain rule step. We multiply by the derivative of the inside. The derivative of 2x plus x to the 1/2. All right, so I'm going to close this parentheses. I'm running out of room here a little bit on the side, so I'm trying to fit it in there. All right, so now we just have to do that last derivative. So we end up with g prime of x equals 1/2 times 3x plus 2x plus x to the 1/2. That whole thing to the 1/2. And whoops, it looks like when I move this over, it looks like the 1 didn't shift over. Let's fix that. All right, let's put in that bracket back again. Alrighty, so this was, okay, so I need this whole thing to the negative 1/2. And now within this bracket, I have 3 plus 1/2 times 2x plus x to the 1/2. That to the negative 1/2. And now finally I do this last part of my derivative. Derivative of 2x is 2. Derivative of x to the 1/2, using the power rule, is 1/2 x to the negative 1/2. Close it. Okay, and then I close that bracket. Be really mindful of your parentheses and your brackets here. When you do this chain rule portion, as we did here, remember, when you take the derivative of the inside, that's only multiplying the other part of the chain rule from which it came from. Okay, so this right here is our answer. In terms of our goals for this section, we have done our second goal, which is doing more examples. It's really important with the chain rule to do a lot of examples. Okay, in the next video, we will do even more examples, but they will be centered around first proving why the derivative of ln of x is 1 over x, and then doing an example that involves using log properties to take a derivative.